President Biden embarks on.
All right, I'm muting everybody. Hello, everybody, and welcome to one more time to our session. So I mute everybody. Yeah, still hear some sound. And the system sound is good. I'm going to share now a quick presentation on our user group. All right. So welcome today to our .NET Zurich user group session, Double Take Machine Learning Day. First, I'd like to give a special thanks to our sponsors offering solutions with value for texture and our location Impact Hub and the Stanford Group and our partners, Azure, Zurich user group, .NET Central, .NET Day, Switzerland, and Swiss Angular. And also today, special thanks to We Are Developers, as we are partnered today on this event for co-promoting, and it's been really great experience. Today is quite interesting because it's Machine Learning Day. We coincided in the date in 23rd of February, as well as other event as well. So in AI 42 that was happening just right before ours, and also on machineLearning.net. That's quite cool. Who we are? Well, it's apart from me, there is Paul, there is Michael, there is Nigel. Hi, Nigel. There is Laurent, Fabian, and Mark, which sometimes they do hosting and help greatly on managing the group. And I admit, what do? We are organizing events, lately this double take from developers to developers, share knowledge, get you excited, hopefully networking included, beer and pizza back in 2019. And we miss that. Do you miss that? Do you miss the pizza, the beer when it was happening? Yeah, Stefan, that's what I like to see. Then what can you do? You can follow us on Twitter at .NET Zurich and LinkedIn. If you are not doing that already, just please do it. Join our meetup group. Otherwise, probably you wouldn't be here because the link is only there. Tell your peers, help us grow, get more people, and conquer the world. And propose content and a speaker. I'm looking at you, Stefan, always. Then our website is .NET-Zurich.ch and our hashtag is .NET Zurich. Feel free to use it if you use Twitter and tweet about us. That will be very welcome. Today's agenda is, we'll have a quick introduction to the Zurich.NET user group, which is this one. We'll have, well, the first session has been canceled. So Ali has suddenly find himself ill, so he could not do that, but we have Marcos Zamana, and he will deliver object detection with machineLearning.net. Once he's done and he has answered the questions, we will stop the streaming and we invite the speakers to stay, and we can have a private discussion with the speakers and between ourselves to discuss openly about machineLearning.net and ask all these questions that you don't want to make in public, apart from the usual chit chat and networking. So I will leave the slide from Ali. He's our Azure architect, technical lead, AI enthusiast. I hope we will have him in the future, but sadly not today. I hope you get well soon, Ali. Our best wishes for you. And then we have Marco Zamana. He's a senior developer at Forward, and he is also a Microsoft MVP on AI, which is quite cool. Marco, how many do we have? How many Microsoft MVPs on AI do we have? 3. You're muted, by the way.
Yeah, it's 3 years. It's
Only
3 years.
3. Okay.
And I started talk about AI from the board of ML.NET.
Okay, nice. So you know the board of ML.NET.
Yes, I started at version 0.3. I think 0.4.
Pretty cool. All right.
So if you want, I can make the session deep dive also.
Yeah, sure. Feel free to go and do a deep dive on your image thing. And I'm happy to give you completely the stage, Marco.
Okay. Okay, I started with some basics. So I share the screen just a little bit slide. I think 3 or 4, not more because it's tedious after. And wait a moment that I share the screen so everybody can see.
Right. Meanwhile, if you have any question, Marco was really daring to tell me that you can ask him anything at any moment.
Yes.
All right. So feel free to, at one point you have any question, unmute yourself, ask the question, and that's it. Unmute yourself back.
Okay. Can you see my monitor, my screen? Okay.
Yes.
Okay, go on. So today, ML.NET. This is not my friend, or this is not my brother. It's me. When I was a very long blonde hair, and when I was a very beautiful guy for all the girls in the world. And these are my contacts. I'm a most valuable professional for artificial intelligence about 3 years. And today I talk to you about
Marco,
ML.NET.
I have a question. What happened? Did you start coding in machineLearning.net or?
Well, I think I started with some startups that are my sons, my daughter, and so I lost all my hair.
Sounds fair.
And maybe there are some beer in the middle because I live in Valpolicella, so we have a lot of wine around. I have a lot of wine around me, and maybe.
That's definitely not good. Well, maybe yes.
Maybe yes. Well, today we talk about ML.NET. ML.NET is a cross-platform open source framework that can help us to insert artificial intelligence in our .NET application. It's a very powerful framework because allows net developer to develop, train their own models. This is a particular aspect that I want to subline. The develop, train, and net developers. This is a very big difference between other framework because the modularity of this framework is very powerful. We'll see after. I will see some aspect that can help us to improve all the concept of the developer in the developer of application, and can help us all we will see all the concept of developer also in the ALM concept of application. ALM, application lifecycle management, is two different things because the one is the vision of the developer that is based on the code, is based on the algorithm to use for create a very powerful model. The other vision is the concept of quality, the concept of we can maybe you have already listen the concept of MLOps, for example, is a quality concept. Is very different between the developer vision, is another vision. ML.NET is a framework that can help us in these two kind of vision of our code. I turn back later. I turn on this aspect later. How we can use ML.NET? We can use as a Nuget package. And this is a very powerful strategy in our application because we can use inside our desktop app, inside our web app, our NTR app, microservices app. For example, we can use inside an Azure function, for example. I make a sample where I use some custom I use object detection inside image using Azure function, for example. Or we can use inside our web API, also in client side and also in server side. There is no worry about that. We have Nuget packages that we can use inside our application. So we have a very modular solution that give us the opportunity to improve all our application. There are three types of three methods that we can use for use MLNET. The first is API. Today we will see some particular aspect of the API. So we open Visual Studio or Visual Studio Code, and we start to make an experiment inside our console application, for example. So we started to use the iData view. We start to use trainers, the transforms, or we can start to use the extension. Today, we use object detection, so we use our own NX model, and we can make a particular object detection in a particular photo. But there are two other things, two other methods. The first is the CLI. That is a particular tool that we can use inside our console application, for inside our command line, sorry. And the other is a Model Builder in Visual Studio. Model Builder in Visual Studio is a very powerful tool that can help us, maybe we can try after, can help us to create a model on scratch, on the base of what we wanted to do. When I started to talk ML.NET, I started to define the importance of understanding the question. The concept of understanding the question is the guide that we have for elaborate our dataset and create our model. When a customer come to us and ask, I have a dataset and I want to apply artificial intelligence, I usually I tell to him, but what do you want to do? Because it's very important to understand that is not everything artificial intelligence, but it's important to understand that one dataset can help us to respond to one question, to answer to one question. And usually this dataset is not good for this question. So, and Model Builder is a tool that can help us to guide, to arrive to one model that we can use inside our application. But if we want to create a powerful, a strong data set, we have to analyze our data and make an experiment very, very deep, very, very strong, and absolutely with our friend data analyst in our side. Because one aspect is the developer, one aspect is data scientist. Data scientists make, from my opinion, 18% of the job. The developer apply this job inside the code. We can do in Python, we can do in ML.NET. There is a concept that after we can analyze the benchmark, what we want. But maybe this the job of the application of machine learning is around these two figures that are developer and data analyst or data scientist. Yeah. So Model Builder, all the three kinds use this particular framework. We have a layer with iData view trainers transform AutoML extension. We support two frameworks, the .NET Core, obviously .NET 6, and .NET Framework Normal. We have the trios, Windows, Linux, and macOS, and supported hardware are 86 and 64. There are also the support for ARM now. What are the components? We have all the components are Nuget packages that give us the API for build, train, and run any model. Inside that are the aspect of the framework, we have these API that are API for transformation of our data inside our experiment, the trainers, and miscellaneous. There are a lot of extensions. You see inside this slide the TensorFlow logo and ONNX logo. Yes, because you can use ML.NET with a model created inside the TensorFlow. And we can use ML.NET for make a prediction or an inference inside with a model of an ONNX model. This is the last slide because is an aspect that is central inside the framework. There are two concepts. The first concept is build model. The second concept is use the model. You know that a Nuget package is a simple things that we can use in all applications that we have. You have to try and image the building model that is a one application in where we collect the load data, we create a pipeline, we train the model, and we improve the model. Is a circle that use three aspects, sorry, that are iDataView, iEstimator, and iTransformer. This concept is central because this aspect is what help us to create a model. But when we create a model, usually we don't leave it after one prediction. Model must change and must have an improvement, continuous improvement about its accuracy. A very powerful model is a model that is created and when it's created, start its evolution in the years, because data can change, our prediction can change, our questions can change. The importance of this concept is that we can save our model and another application can use it. So we can create also try to understand context in where we have 4, 6, 10 models that can answer to 10 questions different. We can use it. We can use it inside our application only with 2 API, only 2 lines of code. It's very simple. It's obvious that our model must to improve, must to start his story and must improve with a new collection of data and a new improving of our model. The use of model is very simple because we can only make this predict. Is the only API that give us the prediction of our model. As you will see after, I'm very passionate about one sport. You can see is a sport of basket. This player, that is Alan Iverson, one day tell that we talking about practice. So we talking about practice. I start with wait a moment. Well, I can start to see also the part of ML.NET CLI, and I don't have installed because I have inside the slide, so we can see you. I tell you before that there are also the CLI that where we can create our model. CLI is a very powerful tool that we can create and we can simple write this string inside our CLI, our command line, and we can create a classification of our dataset. In this sample, we have, for example, a help labeled .txt that is a text file that inside has two columns. One of the simple sentiment analysis. So we have a sentence that can be positive or negative. And in the second column, there are the label that is 1 or 0. And these use the AutoML for create a model. And the framework start to make a training using the best model that have the best accuracy in the training time that we set inside this string. So if we write inside the sentence that we want training time about 60 minutes, he make some tests on all the algorithm that are inside the framework, and we give us the scaffolding of a console application with all we need for make a training of a model. He creates a model, and we give us the method that we can reuse inside our application for make a prediction inside this model. So he gave us a scaffolding of all we need to do that. The process for all experiments inside MLNET are these three: prepare your data, build and train, and run. These start from the data set. Always we have a data set, and we start to preparing our data for pass the data set to our build and train framework for creating a model that we can run. This is the pipeline of our workflow. The part of the model creation is this, in where we have an app, we have a tool for make a training, for create our ML model. This tool can be the CLI, can be model builder, can be our API. And after we can use the model consumption inside our end user application using our ML model like a simple file. In fact, when we create a model with ML.NET, we create a model that is a zip folder that we can reuse in another place. These are the process. Now we see some other aspects that is very, very cool. That is the aspect of the workflow. Usually, when we started to make the part of machine learning, we started to make get all our historic data to create a build and train, and we make some tests and some evaluation about this model. It's a circle. When our model is created, we can run and predict. As you can see inside this slide, we'll see always this icon, that is the icon of Nuget packages that can permit us to scale every aspect inside this workflow. For example, for build and train, we can have our application. We can have our Docker application, for example. We can have our pod inside a Kubernetes context. If we have our container or if we have our application for make a test and evaluation. If we have our application for make a run or make a prediction, we can always use our model, and we can always use our framework modular in modular mode inside our application. This is the very important aspect because as I tell you before, there are two visions. The first is the vision of the developer. The second is the vision of the workflow. Usually, we have the developer that is using the part of that is using to develop his application. We started to share this code. We make a simple push inside the GitHub or Azure DevOps. Make some collaboration with the colleagues that has in his team. We make a build application, some test application. There are the release, and after this is a monitoring app. This is a simple workflow of a developer. There is no finance usually. But we start to build, we started to maintain, and we started to continuously updating the end user application. But if inside this concept we use ML, how we can do? If we have to insert a machine learning model lifecycle, we have to modify this workflow. And for modify this workflow, we have to apply the context of the model lifecycle. It's not simple the context of our code, but is the evolution of our code and the evolution of our model. So the developer can start to collaborate with each other colleagues. We can start to build application, to test application, release application, monitor application. But when we monitor the application, we monitor also our model. And this model can make some retrain for start is evolution. And this is a very, very, very cool feature because we can help. We can have Azure DevOps that can help us, Azure DevOps or GitHub, and we can use the importance of version our model, start to versioning particular aspect of our model, and start to evaluate our model. Another aspect is that we are using .NET framework. So a simple API can be a simple API that we can test. So if we want to make an evolution of our .NET code, of our .NET ML code, we can make a unit testing with the framework. If I tell you that we can use the simple API of the framework to make a unit testing, and we can make a pipeline for understanding that our model doesn't have to go out if it doesn't have 18% of accuracy of our model, is a simple task that we can do inside our pipeline. Simply using the unit testing. Maybe after I can give you, I can make less abstract this concept, because usually is a session that I make in 1 hour. This, but today we try to make object detection, and after, if we have 1 minute, I wanted to see you the piece of code that with this particular aspect. Okay, so as I tell you before, I started with I have started with a particular sample today. That is a sample for that is based on object detection. The starting point is the point about basketball. I love basketball. I love everything of basketball. I love Eurolega, but I love also the part of NBA. There is one player that I loved in my life, that is Kobe Bryant. And today I have make a particular sample for object detection of this player inside a screen. Let's see. You can see my share is going down. I think that is going down. I try screen 2. You can see? Yes, okay. So I start with a video that is this. This is the last game of Kobe Bryant. This is the player that is unfortunately is not with us, and is one of the best player. And I see this video and I have an idea to try to make a object detection of this player inside this particular review. What I have to do? I have downloaded the video and I have created a data set of images. What is a data set of images? Is this, I see you, inside image. I have make all these inside, you see? These are all images of, is about 525 images. I use it more or less, but inside I have, for example, a frame of the action. You see, we have a Kobe Bryant and other players. Now, there are a lot of tools that I could use for make tagging of image. For starting to this demo, usually I have to training a model to understand that this set of pixels is Kobe Bryant. For learning this, I have to use some tools that can help us, for me, to train the model and tell, this is, for me, this set of pixels is very important. So for me, this part of pixel needs to be tagged. I use one tool that is very cool, that is Custom Vision. Custom Vision is a tool inside the cognitive services world that can help us to make this particular tagging. But it doesn't make only this. It can give us the opportunity to create also an API where we can make a prediction and we can make a custom vision. But I didn't do so. Let's do. What I have to do, I have uploaded all these images and I have make the tagging. As you can see, I have defined the object. These are, you see, I have tagged Kobe. I have tagged, and I have make a 1 hour, one hour job in where I tagged all the position of Kobe Bryant inside these frames. The starting point was that I have to make a relevation of the part of pixel in a video, but unfortunately I don't have I don't have a time necessary to do that. But
Marco, question
yes.
there. How many pictures or frames did you tag? More or less this image or vision model, how many do you need to tag to become more or less useful?
It's a very good question because it depends. It depends because in this particular case, I have seen that 100 and I think 180, 183, it was a little bit under sufficiency, a little bit under, because there is obviously a photo, a frame in where we have a lot of objects that are similar. We have other players. we have a background that can help us in reality, but the model can need a more frame for better improve performance. The rule is more data you can put it there is better. Custom vision has also a very interesting quick test that can help you to try to make some tests of some images, and you can analyze if it's good or not. For example, I pick up this. And you can see a probability of 83%, but I have the face. It's a very easy. Another aspect is the threshold. The threshold is a parameter that you can use inside the experiment for define the sensibility of the recognition inside the image. So if you have a threshold that is 90%, for example, it doesn't find Kobe Bryant. Usually, you can make some evaluation in the test of your model, and you try to improve this parameter. In this case, I tagged 183. And I see that in particular case, that a threshold of 30% is it find the player inside the image. It's not simple. I have a lot of untagged image inside that I didn't tag because it was okay with the 100. But we have a trainer model. In this case, we have a maker training, and this is the iteration review that give us custom vision, where we have the precision, the recall, and the mean average precision. These are all data that are important for us, but one important data is this, is the aspect that we can make the training of our model in two modes. The first is the quick training. I do a quick training because it's is a minute training. But the advanced training, we can make a training with of an hour, of a lot of hours. And this is a very accuracy training that can give us the opportunity to improve our model a lot of. So more data is possible to improve, and also big training, because we have a service, a custom vision that can help us to create a model very powerful. But in this case, the model needs us. We don't have to publish. We don't have to create an API to call from outside. We need a model. For the model, we must to make an export. Make an export. We have a six option. The first is Core ML, the TensorFlow, OnNX model, Dockerfile, OpenVINO, and Vision AI Dev Kit. We need the OnNX model, and simply we can do download. What happened when we download? We download a model that is. I see you.
Marco,
yes.
I think the choice you made is significant. You chose ONX instead of others. Would you dare explain a bit to our audience what is ONX and why did you pick it?
Why I pick it on an X? Huh?
Yep.
I see you. because we is first of all a generic model that we can use in a lot of cases, and also it has a very good integration inside MLNet. I see you why. The starting point of a model NNX is that when you download the file, you download this compress file. Inside, you'll find the model, that is this. You can find the label, that is a simple text file that inside has the label, that is copied. And we have some sample. Inside you can find a C# object detection or a Python object detection, because NNX is a model that is generic. You can use everywhere. You can use in Python, you can use in ML.NET. It's a very, very powerful for this. Is a very, very strong feature. But for ML.NET, we can use this tool that is Neutron for Netron for analyze our model. This is our model. We have in the data all the specification of our model on an X format V3, and we have the data of input. We have the specification of our data inputs, and these are the same data input that we go to define inside our ONNX input. I started with a jump in the code, but in this moment, we try to apply the concept of ONNX model, what we have to do inside the code. ML.NET, for create a model in ML.NET, you have to define the model input and the model output. The model input is a simple class in where you define what are the data that you can that is the input data for make a training of our model. In this case, we have to use a simple bitmap image. Okay, and we have to set the image settings. These image settings are the height and the width of our image. 416, if you can see, is the same. 4 and 16. Okay.
Could you zoom in a little bit, please? It's difficult to see the details.
Oh. Okay. You see?
Yes, that's much better.
Yeah.
Okay.
Thank you, Kay, for the comment.
Okay. And we have 416 for the height and for the width. This is the definition of the image.
Can you, Marco, can you zoom a bit more on the code to make it a bit like, yeah, a bit more maybe? I think that now it's good, Kay. I think I see it perfectly now. So yeah, it's great.
Okay.
Thank you.
So if we have to do the same thing with a sentiment analysis, in this case, I have to write public class and the definition of the sentiment analysis. So I have two simple properties. In this case, I have only the image because it's the image in where I have to do something. In the case in where I have to do the sentiment analysis is another kind of experiment. Okay, so I have defined the ONNX input and I have defined the ONNX output. Where did I find these? I find inside the model output. If you can see, you see model output 0, and this model output 0 type float. In fact, is a float, and I defined with the data notation the column name that is model output 0. and the detected box is a name that I use. Simple. We have defined the type T of input and the type T of output. But we have a model, because this is a model that is already trained. We have to make a prediction. And after, we have to make some boundary boxes for define and for find our player inside our code, inside our photo, sorry. So let's go to the program. Okay. We start with a simple main, so it's a simple console application in this case. We start from this object. These objects are the core object of ML.NET. All is around ML context. ML context, you can imagine something like a data context in native framework. It's the same thing. It's an object that has inside. Wait, my personal computer is very powerful. That has inside a lot of catalog that are our algorithm that we can use, our algorithm class that we can use inside ML.NET. For example, we have a catalog of binary classification, a catalog of multi-classification, regression, clustering, ranking, anomaly detection, and go on. This is all the starting point of our context. So the next part is the transform. You remember the slide? We have the context, we have a transform. The transform are aspects that are using inside our experiment for making transformation of our data, for making after a prediction. ML.NET has also this particularly notation that is the concept to make this append is a very powerful part of the framework that can give us the opportunity to make the adding of step by step, like a pipeline. We can append a particular command or transformation inside our context. It is a very cool feature. In this case, we have to make a resizing of our image, because you can see that we have the definition of the image. We have see before that it was this 416 and 416. So all the image that we pass through the model, we have to resize. I have make another POC that make object detection inside a particular document, and the importance of the resizing, it was very powerful when you have to apply, for example, a denoising on the image, because maybe you have to make an OCR inside. In this case, yes.
Can you zoom it a bit? I think some members maybe don't have that much resolution. Thanks.
Oh, okay. I tried this, but it's very.
I think this tool with control and the wheel, you can zoom in and out when you are in the visualization. So you need to click on the center. I think.
No. Wait.
Control plus maybe.
Maybe. No. Don't
worry then. Oh yeah, on the top right, you have this plus in the zoom.
Oh wait. Okay. 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 Maybe it's good.
You can stop in. You can put it 100. Can you go back to Netron?
Okay.
Yeah, on the Netron interface, do you see on the top left corner? There is Stefan Polsi is pointing at there. So there is a plus and a minus. Go up, go up, go up, go up, go up, go up, up. Where you see Imposta Audio Professionali, just below on the right corner there is the minus and the plus. You don't see that.
Oh. Okay, you maybe the next time.
Okay.
Okay.
Don't worry about that.
Well, this is the starting point. It was 416 and 416. When we started to train the model and we start to pass for a prediction, we have to resize the image for having the same analysis. In this case, we have make a resizing of an images. Also, if you can see the documentation of the framework is very, very good. In fact, you can see the resizing image, the kind, there is all explaining inside the documentation. And you have to apply the type of the resizing that you can find. You can try to fill, you can try to isocrop, you can try to isopad. You must to define the data column name and to pass the variable that we have set inside the ONNX input. And after we make some abstraction and we apply the model. So we have used 3 API of this image estimator catalog. And this is very, very simple. But after, we have to fit our model and to create the prediction engine. The fit API is a method that can help us to use a model for have what we need to make a prediction. In fact, the fit of the model consists to pick up our model and make it active for making a prediction after. I give you in a simplistic case, but in this case is the API method for the prediction. So we have only one that is a predict. This give us the prediction that are an ONNX output type. I see you before. That is a float value that can give us the opportunity to make a parse of an output. And so these are all the code that can help you to make analysis on the photo and make a boundary box inside the object that you make the detection. So in this case, you go to do extract boundary box, a mapping, and you have you have to analyze the confidence of the object that you have analyzed, that you have picked, with the probability threshold that I tell you before. The threshold is a parameter that in this case I set to 0.2. I set very, very low for be sure that the model can pick up my object in a very good way. So if we can make run this copy console detection to go, maybe after I make a I have a prediction of coverage of 50%. In this case, the model has make a good prediction inside. The threshold is very, very low, so we need to tag another images, a very lot of another images. It's very, very cool. If you have, for example, in a document is more simple because you have a different background. You have obviously a more simple way to delimit the section that you need. So it could be more simple. In this case, there are a lot of objects in the background. So the model for make a good prediction, you need a very lot of images or frame that can improve his accuracy.
This model, is this only made of these pictures? So here the model has only seen the same pictures over and over, or is it trained on different matches?
I train different matches of image. This image, it wasn't in the model. It wasn't in the training set that I use in custom vision. And it is obvious that are very similar in this case. But the position of the object inside the image is very important. For example, if I have 200 of images of the object inside the monitor like this, I can always predict that the object is in this position. But if I have the object in another position like this, it's different.
He wouldn't recognize this in this case, or
we can try.
Okay.
We can try. I tried this. I tried this, and simply this. You see 23%.
Okay, and it will be even lower if he was wearing the other kind of shirt or something.
Yes, because you need 100 of images of this vision, of this angle, for understand that this object.
Okay.
It depends. There are a lot of. For example, this it was difficult. This it was more difficult. We can try. I'm very curious. This is very difficult because as
so the less Kobe would show up on the spot that he is, the less is the chance that he will be detected as Kobe.
Yes.
Okay.
Yes, you describe very well.
Okay.
24, but the object.
It's the wrong one.
You see, it's not simple because from the angle that you can see the object, it changed. It changed.
That was the quick training as well, right? You did not go for the fast. So that could be interesting as well to try it with, I don't know the algorithm behind this cognitive service for vision, but maybe train it properly, maybe even in Azure Machine Learning and extract the model. I think you can do that if you use notebooks to generate our next model.
Well, if you have notebooks, you can use a GPU inside a computer scenario inside Azure Machine Learning is another concept, is another way, but is a very is a very cool what you can do with obviously is a simple, but you can do a very interesting things also in custom vision. I make one sample 1 year ago about on IKEA for see and the object of an IKEA IKEA object. And I encountered a very lot of difficulties to detect the chair from the particularly, but it was very funny for
Interesting.
But is a very good sample. And this sample has inside the using of MLF of MLNET model, but you can use it also inside the model of TensorFlow. That is obviously another session about this, but you can use inside your application in very easy way. I see if I have. Okay, I wanted to see you another things, but you have to give me 1 second. If it's okay for you.
Of course.
Okay. Okay. I told you before, and that one important aspect is wait, I see this. One important aspect is the concept of MLOps. I recommend to you this. That is Lewis is ML.NET man, and
he's the program manager of ML.NET.
Yes, and this is a ML.NET workshop that you can find in this repo. And one aspect very important of this is an application that you can use to test to improve, and you can see all the phase. So you have the phase 1 that is a get started to prepare data, the training, the evaluation, the save, and the part of MLOps. The part of MLOps, I start to listen about that from Cesar de la Torre, that was the program manager before UIS. And inside you can see how you can create a GitHub action flow for make the MLOps of your training model. So you can set up your data source and you can make a preparation of all your data set, create your pipeline for deploying your data
really cool. Can you please share these 2 links in the chat?
Yes.
And
yes.
I will make sure to put them in the meetup page.
Yes.
And
it's
maybe yeah, the other thing is probably you have other links in your presentation. I don't know if you will share it with us later. That would be really great.
And another aspect is the data frame in Jupyter that I suggest to see. This is a part of on the next model that is you can find also the custom vision. You can find all that you want. Is the steps are the same Usually you start to custom vision and after you see Neutron. One aspect important is that when you create your custom vision model, you have to create a model in, wait a moment, I've lost. It is a thing that I don't tell you before. You have to create a compact type of custom vision. Are different type of custom vision model. You can define this. But if you create a general compact, you have the type of on the next model that you see before that is more simple. Otherwise, if you use another kind of model, maybe you can download another type that is a little bit different to implement. So you have to, I'll see you that you can see the difference. The difference is also that as you can see inside you have only this file. You don't have the scaffolding of C#, another one, another. But you have an image tensor that has another type of dimension, and you have another type of outputs. So you have a more complex output, and you have a dimension of the input that are a little bit different. So you have to apply some tuning inside your ML definition. Okay. Well, I think that I am arrived to the end, Joseph.
All right. So thank you very much. I think it's quite nice to see a bit how to do at least the inferencing part of ML.NET and also using ONX as well. It's pretty cool.
It's very cool tool, and I hope that you can try on your at your home, and if you need if you have some questions, you can write me a mail or you can contact me on LinkedIn, and I will help you.
No, sounds really cool. So now I invite everybody. If you have any question, now it's a moment. Who here has used machine learning.net?
Sorry?
Who in the audience has used machine learning.net, ML.NET?
I use, well,
not you, obviously, you already have, you just introduced it to us. I was mostly asking, anybody has experience here with ML.NET? I play a bit with it, so I really am pretty curious on machine learning. So I play a bit with cognitive services and machine learning.net. So I've already played with ONX, not with the vision service, but with a custom model that I implemented. And I think there is no reason to use anything else than ONX. I think it's a de facto standard that's becoming really, really quick. The default format for interoperability of machine learning.
Is the custom views, is it only for object detection, or can you do other things with it as well?
You can use it also in image classification.
Classification, okay. But you would have to enter the labels, or
yes, okay, I have only used it for the tagging for the label, and for example, you can use the vote for the label. It's the same.
Okay.
I use custom vision because it give me the opportunity to create on the next model quickly.
Okay, so you can either you could just run it over some files, and then it classifies the object, and afterwards you can either combine the tags or even name the tags or something. Is it this possible as well?
Look at me. You can do this. you can use a machine learning model, and now you can see Joseph that is smiling. You can see machine learning model, and you can add a new model builder inside an application Visual Studio, and you can use this scenario. So you can use an object detection using an Azure computing. You can use image classification, value prediction, all that you want. If you use another tool to make a tagging or to make a labeling of your image, after you can use inside this.
Okay, cool. Thank you.
This is a very powerful tool that Microsoft created inside Visual Studio. And if you use object detection, you can scale it on Azure, or you can create an Azure machine learning workspace with all the computing with the GPU that you need.
Can you define the neuron layers and all that stuff, or is it pretty much set up and ready to go, or how much do you have to do to start training with the data? Start training with the data set, yeah.
You have to set up all the training computing, and after you use it through this.
Okay, but you don't do your own neuron network, your own, how do I say it?
Model.
Sorry?
Model, machine learning model.
Yeah, not the model. The model is the one that's get trained, but I think more of like usually there's neurons behind it.
Oh yeah, the machine learning algorithm.
The algorithm, yeah. Can you
yeah.
influence that, or is it just set for the use case to best knowledge from Microsoft, or how much can you custom the model or something?
But you can inference. You can inference because you can use it in Azure Machine Learning workspace scenario. So you can improve if you want.
Yeah, exactly. Also, I believe that if you define deep neural network, you can specify the number of layers that you will use for the training.
Okay.
So
yes,
I believe you have certain control even inside ML.NET.
Okay.
The part of Azure Machine Learning workspace is another very cool part of Microsoft. When 3 years ago it was Azure Machine Learning Services, it was the name. In fact, there was Azure Machine Learning that was the tool for make ML with R or Python. And with the powerful UI in where you can create your experiment. And there was Azure Machine Learning Services that if you think services like is similar or to Databricks, okay, similar, but Azure Machine Learning Services help you to create an experiment. So you can create, you can have without ML something that you can help you to create a strong model with a very strong computing a very strong computer under. But you can have also the opportunity to create a model deployed inside an API, for example. So you have a very tool that can help you in all this process. But maybe is another vision, is not a vision of a developer in this case, is a vision of architect for what I think in this case, because you have to analyze the aspect of data analytics, the ingestion of the data. Another aspect cool is the integration of, for example, the integration of Synapse in the world of the cognitive services or notebook world. This is a very, very cool feature. It's time to beer.
I think so. So thank you, everybody. I'm going now to finish the stream unless somebody has any other question. So nobody? Stefan, Nigel, no questions? No? All right.
Actually, there's one thing that how is it? Well, a couple of years ago, I saw some presentations that you can combine two models together. Let's say a model that can identify a human being or a flower, and then you can then make another neural network on top of that, which then identifies whether it's a lily or a rose or whatever.
There is a sample, MLNET sample. I don't remember now. Wait. This. I'll see you the sample of ML.NET, but if I understand correctly the question, the flower, no, is the classification of the flower, yeah. Right? Okay. The classification of the flower starts from dataset that give you the opportunity or the property to define and labeling the flower that you wanted to classify. Is a starting point. So in this case, is a iris classification. Is this sample? You have an iris data that are the input file, the input type. Okay, so you have the sepal length, width, the petal length, the petal width, and the label. And you have the data to prediction, that is a float of the scoring.
Yeah, actually, I'm familiar with this example. What I meant was like in image processing, that you can somehow you have a neural network which is trained to identify a flower or a person, and then you combine on top of that your the model that you want to train. So in a way, then it's I just wondered if that existed actually.
Well, I understand. I think that I understand. I try. You can make multiple prediction. Okay, you can try to make an image classification of the flowers to understand, and it starts obviously by tagging an image with this particular flower, for example. Or you can start, or you can try to training a model for these properties.
Yep.
It's obvious that you can use it each other. You can use in one experiment if you want, but you need to create a data set that can give you the opportunity. You can also create 2 or 3 models for make a 2 or 3 different prediction for understanding that this is a particular type of flower. Okay, but it depends always from the data set that you have and how you want to arrive to the question, to the answer of the question that you need to find. It's not simple. There is not a single way. Okay.
With how do I say, when you chain the models, it's usually for a classification you would have to do first the object detection to see if they're an object and what's the dimensions of the object. In the next step, it will count the petals. It judges the size and everything, and after that, those parameters, it does the classification as which flower, if it's a Gänseblümchen or a rose or whatever it is. So,
well, you can use one moment for have an answer that you can reuse in another question model. So is a concatenation. Is you can use it. Is for example, there was my friend that is a data scientist that told me that He working for a big company that they analyzed very big data context for understand what kind of voucher sell to particular type of customer, and they don't understand why the results of this model wasn't accurate. After they understand that they'll forget one important parameter, that was the age of the people. A particular range of the people that give there the opportunity to make deep analysis and have a regression value that can help to sell voucher correctly, for example. It's not simple, it's very hard, but you can concatenate, you can use it, you can make a very lot of things. There is not one answer about that. I hope that I answer you correctly, Nigel.
Oh yes, thank you very much.
One thing, if there is nothing more, I like to show one thing, because I think I'm basically in love with ONX. I think it's the coolest thing ever. But unless anybody has any more question for Marco, then I'll show something. Screen one. Yep. So can you see my screen?
Yes.
Perfect. So here I am now on onx.ai. And one thing which is cool at one moment, there is something called Model Zoo. And on tools and supported tools, you can find these Lutz Rider. And if you go there, you end up on this GitHub page. And this is probably where you can create your models. So these are some ready models. And one of them, for example, is for text comprehension. And you can find this GPT-2, which is the predecessor of GPT-3, this OpenAI. And you open, let me see if I can Neutron, this tool that Marco showed, which is created by Lutz Rider. By the way, with Control and the wheel, you can make it smaller. And just dragging, you can, not this, you can go to the top. This is a very hyper complex
yes
model, but I think it's cool. You also, what we were saying is this plus and this minus, and you can explore and see how it works if you fully understand it. I do not, but the thing is, you can click on the input, and here is what you showed before, that you have to map that on the input. In your case, it's simple, a bitmap, but here is, well, quite overly complex, right? And also at the end, the output, you can skip everything and go to the bottom and see the output, and being able to use, this case, GPT-3 or any super model like this one.
But it's very cool, because if you use this model and you use inside ML.NET, you can find all this property in the output.
Yes.
Is very cool, because you have simply defined in your class, and after this object come to you when you make a prediction. Yes,
exactly. I love this tool. I think it's pretty cool. It's from Lutz Rider. I think he has done quite some awesome tools. Let me grab these, show it here. It's even in full open source. So it's, well, thank you, Lutz. I think it's pretty awesome. So I just wanted to show it because I think it's pretty cool. And you have a lot of models in the zoo. And as Marco did, you could create your own too. Either, yeah.
I try.
Yes. I think it's pretty awesome, right? The concept of training in the cloud and running it everywhere with .NET, either it's Linux, Windows, Mac OS, your mobile device, your tablet, or even in IoT Edge. That's pretty incredible.
I remember when I do this. I see you. The first time that I do this I push it this. I make the heart disease detection. Is mine. I send it to. I make a pull request about that.
Cool.
And I remember that it was a sampling where the dataset has 74 columns, but for the experiment, only 14 needed. So it was for me clear to explain to people that a big data set doesn't always give you all that you need. Maybe you can need only 10 columns, not 74,
cool.
For example.
Yeah, understanding the data is key. I think you're absolutely correct. That's pretty cool. Nice.
Yes,
so you are into open source.
Yes. It was very, very cool because in these years I had a pressure problem in with a small heart disease, and so there was all the part of machine learning analysis of images of TAC, magnetic resonance, and other. And I find that this data set in the UCI, and I try to make a prediction, and I make a pull request. I was very, very glad about that.
Cool. Awesome. All right. Do you have a GitHub? Is that in your slides?
Yes.
Perfect.
Yes.
So if you send me later, I publish it on the meetup group, and I think that's essentially it. Nay, you asked me if you can share the ONX link of the samples. I put these two GitHub links. Is that what you were asking?
Yes, thank you.
Perfect. Good. If there are more questions, I will stop the live stream. 1,